All right, next up we have solving by elimination. And this is, I think, just a little bit easier of a method for most people than substitution. So I'm going to read through the steps to begin. So step one, we're going to line up the equations. And what I mean by this is make sure the x's are stacked on top of each other, the y's, and then make sure that it's the equals and then the numbers stacked. And then what we want to do is we want to look for either one of the variables. We want their coefficients to be opposites, like a positive 3 and a negative 3, and opposites of the same number, positive 5 and negative 5. And if we don't have that, we have to multiply an equation by something to get it. Sometimes those opposites will already be there. And then what we do is we add straight down. And if you think about it, positive 5 and negative 5 add to 0. That's our goal. We want to eliminate one of the variables. We want to get one of the variables to 0. And so that's why we do a positive and a negative of the same number. And then once we eliminate a variable, it's really easy to solve. And that gives us one of our, either our x or our y. So let's look at number 1, and you first want to scan it. Make sure it's stacked, which it is. See if there is a positive and a negative. And I actually start out having it, a positive 10y and a negative 10. And we want to make sure those opposites are with the same variable. Not one with x, one with y. They have to be the same. And so now that I have it, I don't even have to multiply by anything. All I'm going to do is I'm going to add straight down. So negative 6x and 4x is negative 2x. The y's would cancel, equals negative 14 plus 6 is negative 8. And then what we do is we divide both sides by negative 2 to get x equals 4. So we have one of our variables. Now in order to find the other variable, we can pick either original equation. We pick either one. It doesn't matter. I tend to go with the ones that have the smaller numbers. I don't know. So let's go with the second one. 4x minus 10y equals 6. I know my x is 4. So I'm going to plug that in. And this becomes 16 minus 10y equals 6. And then if I subtract 16 from both sides, we get negative 10y equals negative 10. And then if we divide both sides by negative 10, we get y equals 1. And when I put this together as a point, 4, 1. So those two lines cross at 4, 1. Let's do number 2. When I scan it, I see I do have a minus 2 and a positive 2y. So that's going to work out really nice. When I add straight down, we get 9x equals negative 27, because those would cancel. Then when I divide both sides by 9, we get x equals negative 3. Pick either one, either original equation you want to plug in. Let's pick the first one. 7x minus 2y equals negative 1. So I'm going to plug in that negative 3. Negative 21 minus 2y equals negative 1. Then if I add 21 to both sides, we get negative 2y equals 20. And dividing by negative 2 gives me y equals negative 10. So my solution is negative 3, negative 10. All right, number 3. When I scan this, I don't see anything that's opposites, but I do see something that is close. Notice we have both of our x's have a positive 2 coefficient. Remember, we need one of them positive, one of them negative. So we can pick either one. These are pretty simple. We just pick either one and we can multiply that entire equation by negative 1. And when you multiply, you have to multiply everything by negative 1. So that will turn into negative 2x plus 5y equals negative 2. And then I'm going to rewrite my other equation. We don't have to change that one. And when you multiply an entire equation, every number in that equation, by something, it really doesn't change the equation. It changes what it looks like, but it doesn't change anything about the actual graph. But doing so made it so that we had a negative 2x and a positive 2x. And so then when I add straight down, the x's cancel this time, leaving me with 14y equals negative 28. And then when I divide both sides by 14, I get y equals negative 2. Now let's pick any of those original equations. I'll just pick the first one. 2x minus 5y equals 2. We know that y is negative 2, so I'm going to replace the y with negative 2. This gives me 2x plus 10 equals 2. Subtracting 10 gives me 2x equals negative 8. And dividing by 2 gives me x equals negative 4. So my solution, make sure you put your x first, is negative 4, negative 2. All right, number 4. Don't have any straight up opposites, but if you look, we're looking to create opposites. So if I were to multiply this top equation by 2, that would give me negative 12x minus 10y equals 28, and 12x plus 9y equals negative 18. And that created those opposites that I was looking for. Sometimes there's more than one option when you're multiplying. Sometimes there's several different things you could do. Just go with the first one that comes to your head. And sometimes some of them are more obvious. So in this case, the x's cancel, and negative 10y and 9y is negative 1y. This would be equals 10. And then if we divide by -1, we get y equals -10. Okay. Pick one of those to plug in. Let's pick, I don't know, the top one. -6x minus 5y equals 14. This would be -6x minus 5. I'm going to plug in a -10 because my y is -10. Oops. This becomes -6x plus 50 equals 14. Subtracting 50 from both sides gives me -6x equals -36. And dividing by -6 gives me x equals 6. So my solution is 6, -10. Number 5, I want you to try number 5 on your own. It follows the same kind of process, and I'm just going to give you the solution. So the solution to number 5 is -3, 0. Try that one out and make sure that you can get -3, 0. All right, number 6. If I'm looking for opposites. There's nothing that I can really multiply one of them by to get my opposites. And so sometimes you need to multiply both of them. And there's a couple ways you could go about it, but something that comes to my mind is I say, well, if I multiply the top one by 3 and the bottom one by 5, these y's will turn into a 30 and a -30. And that's one option that you could have went with. Again, there could have been multiple options, but your goal is just to get those opposites. So we get 12x plus 30y equals -72. And 35x minus 30y equals 25. My y's are going to cancel. 35 and 12 make 47x equals -47. And then if I divide both sides by 47, we get x equals -1. And then if I go to plug in, I'll just pick the top equation. My x is -1, so I'm going to replace that with -1. This becomes -4 plus 10y equals -24. If I add 4 to both sides, I get 10y equals -20. So y equals -2. And my solution is -1, -2. Alright, let's got a couple more, and then we have some applications. I know this is a longer video. Alright, so let's pick one, and I see if I multiply this bottom equation by 3. Let's try that one. That will get me a, can't do 3, because that'll give me negative and negative. I need to multiply by -3. So if I multiply by -3, -6x minus 15y on top equals -15. And then I have a positive 6x, a positive 15y, and a positive 15. When I go to add down, the x's become 0x, the y's become 0y, and this becomes 0. When this happens, that means that you really have the same line. So it's infinite solutions. When everything cancels, it's infinite solutions. Now let's look at number 8. I can multiply number 8 by, let's say, -2. That will give me a -2x plus 14y equals -6. And 2x minus 14y equals -4. This one you might want to say, that one's infinite solutions too. However, the x's canceled, the y's canceled, but these last numbers did not. Those are -10. So really I'm saying that 0 equals -10, which is not true. That means that I have no solutions. So if absolutely everything turns to 0, it's infinite solutions. If the x's and y's cancel, but what it's equal to doesn't, then it's no solution. All right, let's get into, we have 3 applications and that's it. It shouldn't take too much longer. So when we're doing applications, we want to look at our variables. What specifically are we talking about? Then we're going to set up some equations. And these equations, guys, it could be a variety of things. It's not set. You always do it this way. You really have to think about the story. You really have to think about what's going on. And you'll probably see some recurrent examples, and you'll start seeing a pattern with how they're set up. And most of the time, these have to do something with money. A lot of times, these deal with money. So let's read the first one. Marcy bought a total of 20 used books and CDs. So not 20 books. She had CDs and books. Altogether, it was 20. So we're talking about CDs and books. So I'm going to use the variables B for books and C for CDs. And out of all of these, she spent $54.50. So in her bag, she had 20 items, CDs and books. She spent $54.50. We know that the books cost $1.50 and the CDs cost $5. We want to know how many of each item she bought. So the first thing we look at is we know a total number of items. So a total number of items takes all of her books and all of her CDs, and that is 20. First of all, cost has nothing to do with it. We just know that there are 20 items in a bag. Then we also know that books were $1.50 each, so 1.5 times the number, and CDs were $5 each, and she spent a total of $54.50. In an example like this, if you're going to use the money, so we used the $1.50 and the 5, we also need to use the $54.50 all in the same equation. It wouldn't make sense to set the first one equal to $54.50. So you have to really pay attention with how you're setting these up. And it can be confusing. It really can. So we're going to do this one by elimination. And you possibly could use substitution, but because this is in the elimination lesson, we'll use that method. So let's say that I multiply this top one by -5. And I've not made enough room for myself. That gives us -5b minus 5c equals -100. And then I have 1.5b plus 5c equals 54.5. I need to add straight down. That'll give me -3.5b equals -45.5. And then if I divide both sides by -3.5, we get b equals 13. Then I'm going to go try to find out how the number of CDs. The top one looks pretty easy. 13 plus C equals 20. That means that C equals 7. So we had 13 books, 7 CDs. Number 8. Landon babysits and he works part-time at the water park over the summer. 1 week he babysat for 3 hours and worked at the water park for 10 hours and he made $109. The next week he babysat for 8 hours and worked at the water park for 12 hours and made $177. How much does Landon make per hour at each job? So our two variables, we're going to have B for babysitting and W for water park. Now this one's a little different because it didn't really give you just one like total of something. It gave 2 totally different scenarios. Both of them included money. So we're going to set these up a little different. This one we're going to say, all right, 3B plus 10W equals 109. 3 hours of babysitting, 10 hours of water park, and he made $109. And then 8B plus 12W equals 177. Neither one of these really gives me a good, I can't really multiply one of them by something to get my opposites. So we need to multiply both of them. 24 would be an easy number to get to with my B's. So I can multiply the top one by -8 and the bottom one by 3. You could have done 8 and -3 as well. Actually, let's do that because that's what I did on my example that I have written down. All right, let's do 8 and -3. So this one becomes 24B plus 80W equals 872. Then we have -24B minus 36W equals -531. And then when I add, the cancel, giving me 44W equals 341. And dividing by 44 gives me $7.75. So he makes $7.75 at the water park. Then we can plug back in, and I prefer to plug into the original equations because they're smaller numbers. 3b plus 10, now I know 775, equals 109. That's 3b plus 77.5 equals 109. And then that's 3b equals 31.5, or b equals 10.5. Oops. Meaning when he babysits, he gets $10.50 an hour. And at the water park, he gets $7.75 an hour. All right, last one. Hope you've stayed with me. All right, Kent has a collection of pennies and nickels. I'm going to write that down. P is pennies, N is nickels. And they have a value of $1.98, and the total number of pennies and nickels he has is 82. How many of each coin does he have? So similar to the first one, we have a total number of pennies and nickels. So P plus N equals 82. And we also know that a penny is 1 cent and a nickel is 5 cents. So 0.01 P plus 0.05 N equals 198. Notice I only pulled the the actual value, the money, in that second equation. The first one was only a total number. All right. So if I multiply the bottom one by 20, or really, I guess, negative 20, that will make my ends cancel. So let's see. P plus N equals 82. We'll get a negative 0.2 P. No, not plus. Minus N, because 0.05 times negative 20 is negative 1. If you have 20 nickels, you have $1. So minus N equals negative 39.6. I know these decimals are ugly. And then if I add straight down, the ends cancel, leaving me with 0.8 P equals 4240. And dividing both sides by 0.8, we get P equals 53. And plugging back in, I'll pick the first one. Oops. $53 plus N equals 82. Subtracting 53 gives me N equals 29. So he has 53 pennies and 29 nickels. I know that was a long one. Thank you for bearing with me. And if you have any questions, let me know. Have a good day.